Okay, so now we've reached our last segment of this learning opportunity, which will mainly look at the counting rules in probability, which is permutation and combination. So the probability calculation, as we can observe now, involve counting the number of event outcome R, which we've already seen in some aspect. These are counted out of the total of the possible outcome, which is n, and they are expressed in ratio. So these counting rules just assist in finding the value of R and n. And permutation, in other words, is just the total numbers of different way in which something can happen. We will see it more as we look at the example. So we have the multiplication rules of counting for single event, which is n factorial. By n factorial, it's just n times the n minus 1, the value, and so on. You will see it as well during the example just now when I switch to the blackboard. The permutation rule, this is the formula for the permutation rule. R, the number of objects selected at the time, and n, the total number of objects. So the permutation rule will be n factorial divided by n minus r factorial. And combination rule now is also the same, but you see now there's r factorial and then there's n minus r, both in bracket factorial. The main difference between permutation and combination is in permutation rule, the order of selection is important, but when it comes to combination rule, the order of selection is actually not important. Okay. So multiplication are rules of counting for a single event. So like I said, we have n factorial for a single event, and for combined event we have n times 1 times 2 times 3. So now let's switch onto the blackboard and see in one of the examples how this is performed. Alright, so now let's look at the scenario here. Let's just read the question. And so they say, in a 6-lane swimming pool, how many unique arrangement or permutation of 6 swimmers can be considered, and what is the single event here? So if you look at our formula here, n factorial, for this scenario, our n is equal to 6. So it becomes now 6 factorial. So by 6 factorial, now what we do is we do 6 times 5 times 4 times 3 times 2 times 1. And this gives us what? 720. So those are the different swimming arrangement. These are the different swimming arrangement possible. Alright, so basically this is what we mean by n factorial. So anything factorial, you just start by that number and you keep going down, and so on. But the nice thing is that in our modern day calculator, or just in our calculator if I may say, you see that there's already a button there. You must just look for it as soon as you write a number, let's say 8, and then there's this sign which means factorial, and that can work it out for you. And what else are we going to look at here? Now when we have combined event, we are being told here a restaurant has a choice of 4 starters, 10 mains, 6 dessert, and what is the total number of possibility? If you remember our formula here, we had n1 times n of 2, n of 3, and n of whatever number we had. So here what you do, it's simple. All we have to do is just do 4 times 10 times 6, and this is going to be equal to 240. Okay, so basically that's it for this scenario. Okay, so now let's move on to first the permutation rule, right? Just a quick reminder, this is how our formula looks like. N r is equal to n factorial, and this is divided by n minus r, and both in bracket factorial, where we know r is the number of object selected at a time, and n is just the total number of object from which we're selecting, from which to select. I'm gonna keep it there. So let's read this question here, this example here. A factory has 3 machines and 8 possible machine operators. How many distinct assignment or ordering of machine operators to machines are possible? Okay. And the second question is, what's the probability of a particular ordering of machine of having one of the particular ordering machine to the 3 machine? Okay. So yeah, reading that of one of the particular ordering, sorry. So let's start by solving A, considering that our n here is equal to 8. That's the number of possible object from which we can select, and our r is equal to 3, as we can see there. Then this permutation, and you can see here it says ordering. That's how you know that you're working with permutation, because the order is really important here. So this is equal now to 8 factorial divided by 8 minus 3 also factorial. So which is 8 factorial divided by 5 factorial. Well, if you don't have a calculator, or your calculator doesn't have that option, this is where now you go to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. Okay, and what you have is 336 permutation. And question B, we were asked the probability of selecting a particular grouping of the 3. Then that's just the probability here will be P of 1 out of 336. So which is 0.00297. In other words, we have 0.29.7% chance of selecting one of the 3, because these are all the permutation possible. So this is a permutation. Now let's look at the combination one. All right. So combination rule, like we said, a number of different way of selecting or arranging an object, but now here the order of selection is not important. So this is how we write the combination. So it's something like this. Same thing, n is factorial, but now we also have r factorial, n minus r factorial. So this is not to confuse with the previous one. So like this, okay? And we know what r is, the number of object selected at the time and n is just the total that we select from. Okay, so let's read now. The question here, it says a company produces juices or fruit juice in 10 different flavor. A local supermarket sells the product but has only sufficient shelf space to display 3 of the company's units, 10 fruit at a time. How many possible groupings, combination now, of the 3 flavor can the juice company display at a local supermarket? And what is the probability of that a particular combination of the 3 juice flavor will be selected by the company? Okay. So first thing, we know that our n here is 10 and our r is 3. So then you'd write the combination of this will be equal to 10 factorial factor of 3 factorial times 10 minus 3 in bracket factorial, so which is equal now to 10 factorial, 3 factorial, and 7 factorial. Okay, and we know how this goes. Then you have to write now this. You start, but if you have a calculator, this should be easy. It should be very easy to just plot in and do, and you know, this will be very easy for you in a calculator. But okay, let's just do it manually so that we all understand where the values are coming from. And when you take your calculator, you should get 120 combination. Okay, so those are the number of combination. Now the probability of selecting one, question B, all you do is just 1 divided by 120, then you get 0.0083. Therefore you have 0.83% or chances of selecting one. So basically that's it for permutation and combination. Just keep in mind this one, there's a specific order that need to be respected, and this one, the order does not matter. All right.